So, hello everyone, and welcome to this introductory session of a new course that we are going to soon start. And today we are, as I told you, conducting the introductory session for the same. So, the course that we are going to start will be design and detailing of RCC structures using RCDC software. So, once again, before I begin, thank you for joining us this morning. And those who are going to watch this session later on as per their convenience, welcome to them also. So, we will have our introductory session today. The online course we would be soon starting from next week. So, I'll go through this presentation, which will be around 40-45 minutes, and then we can have your questions, queries, suggestions, whatever. Okay. So let us begin with our introductory session. And I'll start with a brief discussion about what actually is RCDC, why this course, why we thought this course should be conducted, then a few things about us, the evolution over the past so many years, how we have evolved over the past years, and how our experience has shaped us, how we are doing things now, our impact for our participants, then a few things about us, and then the details of the course, what are going to be the features of this course, who will benefit from this course, the outcome that we are looking at, and then how to proceed ahead, and then your queries. So I'll speak for next 35-40 minutes, and then we can have uh, discussion, queries, questions, whatever. If you want to message your questions, or if you want to ask your questions, you can type in the chat box on YouTube. And if they are relevant, we will take them then and there. Otherwise, we will take it towards the end. Okay. So let us begin then. I hope my voice is audible. You can see me, and the presentation is also visible on the screen. Okay, so what is RCDC? So RCDC is basically a post processor, and the role of RCDC is mainly to automate or do the design and detailing of various RCC elements. So per se, it will not do analysis on its own. Okay, RCDC, please remember, is not an analysis software. It is a post processor. What do I mean by post processor? So by post processor, I mean that design analysis will be carried out in some other software, and it will take the analysis results as an input, and based on those analysis results as an input, then it will do the process of design and detailing of various RCC elements. So what do I mean that it will do design and detailing? What is the meaning when I say that it will do design of RCC? What do I mean? So basically, design of RCC would mean that whatever size you have provided, it will check that size. Okay, it will calculate the reinforcement, it will calculate the reinforcement, and then it will calculate the, or it will figure out, it will decide the bar dia numbers, layout, etc. Okay, so this is what I mean by design. All right. So it will not do any analysis, I'll repeat. It's a post processor. So it will only do the design of RCC elements. Mainly, it will be checking the size that you have provided in the analysis file, and then it will calculate the reinforcement. It will figure out the bar dia. It will give you the layout, the number, etc. So initially, this a little bit history about this software. This software was developed by a company called as SQ. It was a Mumbai-based company, and they had created this RCDC software, I think sometime in 2010 or 11, okay, or maybe slightly before that also. I don't exactly remember the year in which they had created this software. I think somewhere in 2010 or 11 maybe. So this initially this software was created to act as a post processor for StatPro, and then eventually they added capabilities to take the analysis file from ETABS also and do the design work. Then in 2014, I think it was acquired by 13 or 14. It was acquired by Bentley Systems. That is the company which makes Stat Pro and all those softwares. So it was acquired by Bentley Systems, and then as of now, the RCDC has been integrated into the Stat Pro software itself. Okay, so integrated into Stat Pro. So the integration is complete, and not only RCDC, there were some couple of other softwares also like PlanWin and RCDC, and there was a Steel Auto Detailer. So all those softwares were made by SQ Future Tech Private Limited, and when the company was acquired by Bentley Systems, now all these softwares were sort of integrated into the Stat Pro interface itself. Having said that, RCDC, even though it has been acquired by Bentley, it still can do the design and detailing for ETABs also. Okay, so it still has the capability to do the design work for ETABs. Of course, with STAD it has a complete integration, but for ETABs also it can do the design and detailing part. Okay, so which elements does it cover as of now? So as of now, the design and detailing of uh, slabs, beams, columns, RCC structural walls or shear walls, footings, and pile caps are part of your RCDC software as of now. In the current RCDC version, it has also included the water tank structures. But those water tank structures right now it does only for the Euro codes. Okay, so Indian code has not been integrated into the RCDC suite as of now for water tank structures. But other than that, it will do for slabs, beams, columns, shear walls, footings, pile caps, etc. So it's a post processor. Always remember that it will not carry out analysis on its own. You need to bring the analysis file from a software like STAD and ETABS, and then it will do the design and detailing part work for you. Okay. Yeah. So, right. So I have already discussed this. After the analysis is run in the software like STAD or ETABS, then you can use the RCDC for size finalization, for reinforcement calculation, etc. Okay. Then what else RCDC does? So after the introduction of your uh, IS 13920 which had lot of just a minute, which had lot of my pointer is not working. Just give me a minute. Actually, I'm not able to switch on my pointer. Yeah. So after the introduction of IS 13920 which included lot of provisions like the beam column capacity ratio. Okay, beam column capacity ratio was introduced. The joint shear check was introduced. Then it also introduced some additional clauses like VC has to be taken equal to 0 for shear design. Okay, there were some clauses introduced for RCC structural walls also, or what we can call as shear walls. So after all these new clauses were introduced, the current RCDC is able to correctly calculate the checks and the design required for the new IS 13920 also. So this is a big advantage that RCDC now offers. So as of now, STAD, if you use STAT Pro, it is not able to do the joint shear check and it is not able to do the BC ratio, isn't it? So that issue has been sort of resolved if you use the RCDC software. Also, if you are using ETABS, I don't know if you are aware or not that ETABS calculates the joint shear ratio incorrectly. So the ETABS joint shear check as per the Indian code, as per the American code, it does it correctly, ACI 318, but the ETABS joint shear check as per uh, IS 13920 is faulty. It has a problem in it. So those issues are also sort of resolved if you are using the RCDC for ductile design and detailing. So this is a new feature. You can also use RCDC for the ductile design and detailing check. Obviously, the usual design as per IS 456 is anyway performed, and then the ductile design and detailing is also performed. The next good feature of RCDC is that it offers great flexibility to the structural engineers to modify and set reinforcement as per desired arrangement. So, what do I mean by this? So, I think you are aware that many times when we do the detailing in a beam, let's say we have a continuous beam, many times we want to set our own sort of reinforcement, isn't it? So as per some site condition or as per the bar that I have or some other issues on site, I want that I would require a specific reinforcement arrangement to be provided. I would wish that these should be my extra bars. Okay, I um sort of want that number of bars in a particular layer should be able to control. I should be able to control the lengths. I should be able to control. So if you want to modify and set reinforcement as per your own arrangement, that feature also RCDC gives you, and by a simple click you can set your own reinforcement. What is the advantage of setting your own reinforcement as per your own desired arrangement? So once you are able to set your own reinforcement, then you can generate your drawings based on that. That is the big advantage, that you can generate drawings on the basis of the reinforcement arrangement that you have set. In fact, it will also check for the reinforcement arrangement that you want to or you wish to provide. So that is a good feature of RCDC, that it offers great flexibility to the engineer to set their own desired arrangement. Okay, and especially this requirement or this feature is extremely useful in case of beams, I would say, and in case of uh, RCC walls, or what we call as shear walls. This feature is extremely useful. Even in case of columns, this can be uh, used to great advantage. Such a feature is not available in StatPro. In StatPro, you cannot set your own desired arrangement of reinforcement, isn't it? In ETABS, you can do that. In ETABS, uh, you can sort of tell the software that this is the reinforcement arrangement I want, but then that process is very cumbersome. In RCDC, that process is very easy, and uh, at a click of a button you can actually set the reinforcement, do the design checking for that reinforcement, and then once you are happy with that reinforcement, you can even generate the drawings as per that arrangement. Not only drawings, you can also generate the BOQ as per that arrangement. So as I was telling you, another important feature of RCDC is that it is able to produce very good reinforcement detailing drawings. Okay, so based on the detailing that you have finalized, the detailing that you have proposed, on the basis of that detailing, as per the codal provisions, obviously it will generate to the scale drawings for you, which you can, I have seen many people use those drawings directly as part of their project drawings. How many of you have seen RCDC outputs being used directly as project drawings? Has anyone seen? So I have seen many projects these days which directly use the RCDC output as part of their construction drawings. So they just take the output from RCDC, they will paste it in their own sheet, and then yeah, that is it. So Mr. Jay is saying he has seen drawings which are directly output from RCDC. So if you are not, see, some people, what they may do, that they will take the output from RCDC, make some minor adjustments, maybe some layer or some color, etc. In fact, those changes can also be made in RCDC itself. There are a lot of options to change the color, text, line type, etc., etc. So you can make some minor adjustments in AutoCAD, take the output from RCDC, then make some minor adjustments and directly use as a part of your project drawing. So I've seen that also being done. So that is another big advantage of using RCDC. And then it can also provide the BOQ. So it can provide you BOQ for RCC items. In BOQ, the important item that I thought is important or is useful is the bar bending schedule that it can prepare. So other items we can also calculate very quickly, but the bar bending schedule it prepares is a good feature, and it's quite accurate, and I would say that is of a great advantage to us if we are doing RCC projects. Okay. Then, so this is all about RCDC. This is all about RCDC. Just a small introduction if you are not aware of what RCDC is. So then why did we think that such a course should be brought out? So for many days we have been thinking, and we were getting this feedback from our participants also, that we should bring a course on RCDC, mainly because, as I told you, that you can use the RCDC software to automate a lot of your design work, to automate the work for RCC projects. Okay. And I think, if you have been doing RCC projects on your own, there's a lot of time we have to invest when we want to do detailing of each and every uh, element like beam, column, etc. Because even though we do on softwares, usually we are not very comfortable with the software output we get. Instead, we don't get very good quality outputs. Even in ETABS, for beams, we will only get the AST, isn't it? We will get only AST, but then the detailing or how I want to arrange those bars, that work most of the times we have to do on our own. So the automation somehow is missing if we are using STAD or ETABS. Okay, so if you are using RCDC, what I have been what I can see is that we can automate those works in RCC projects. Okay, so through this course, that is our intention, to have an in-depth understanding of each and every aspect of the RCDC software. Uh, and in the process, we would like to understand the design and detailing of various RCC elements that RCDC is right now able to design and detail, like slabs, beams, columns, RCC structural walls or shear walls, footings, and pile caps. Through this course, we will also like to learn how the BOQ is prepared in the RCDC and how drawings are generated by RCDC, and which, with minor adjustments, can be used for as construction drawings. And then we will apply those learnings for an actual RCC project also. So these are the things we would like to achieve through this course, and I thought we should conduct this course to address these issues and to be able to use RCDC for our to our advantage. Okay. Yeah. So before I go to what all we will include in this course, just a few things about us. So we have our own consultancy firm, and uh, we work in the field of industrial projects, infrastructural projects, commercial warehousing, and lot of design development projects, peer reviews, repair retrofitting, forensic engineering. So you will see we work in a lot of different fields as consultants, and additionally we also have this training and skill development firm that we have been running since 2015, and we had started initially as an offline training firm, but then since 2020 we have moved completely online. So we do industrial projects, commercial projects, infrastructural projects. We have done some good iconic bridge projects which have been successfully commissioned. Some good conceptual uh, designs we have prepared and are waiting for some government approvals. Then, as I was telling you, initially we used to conduct on offline training in our own office, and then since 2020 we moved online. So we have had good experience of some 8 9 years of conducting sessions, lectures, etc. And since 2020 we have moved completely online, and we have covered around uh, 19 online courses and 2 long-term structural training programs also. So our participants are from all across India. That is the advantage that being online offers. Geography is no limitation. So our participants are from all across India, also from the West Asia or Middle East, African countries, South African countries, uh, East Asian countries. So there are a lot of participants from different countries also. And the good thing is that most of our participants are working professionals or practicing engineers themselves, or postgraduate students. Many of our participants are research scholars or PhD candidates, and we have a lot of faculty members and teachers also. So it's a great diverse group that we always have, and which ensures we get a good peer to peer learning in our courses. So over the years, as I was telling you, that we have been conducting short term courses which focus a lot on theoretical aspects and in depth understanding of a particular topic, along with software proficiency. And till date, we have conducted 19 such courses, and these courses are quite in depth, and they cover or they run for around 60 to 90 hours. So that is almost twice the time that you devote on a particular subject in your semesters, isn't it? In your colleges, a semester on one subject would typically be of 40-45 hours. So in our short term courses, we like to go in depth on a particular topic, and not only in depth theoretical discussion, but we also like to do a lot of work on the software, so that the participants get a strong theoretical base and they are able to use that knowledge for actual project work also. So these are the things that we do in the short term courses. Then we have another series of courses which we call as the project design courses. In this, what we do is that we try to take up an actual project, and then we do it as it would be done in any design office. So that gives a taste of doing actual projects to our participants. So in the past, we had conducted two long-term 6 months online training programs on RCC projects and steel projects, where we had covered four actual projects as a part of these programs. And then we have, of late in the past year, also conducted three project design courses, where we have taken up actual projects and we have been doing them. So for example, an ongoing course as of now is a project design course in steel pedestrian bridge, where we have taken an actual steel pedestrian bridge project and doing it in our live sessions. So three such courses also we have conducted till now. So that has been our strategy. That has been our two pronged approach to conduct short term courses which focus on getting a great theoretical, strong theoretical base, and having a deep, in depth understanding and developing a good software proficiency. That is the aim and objective of conducting short term courses. And in the project design course series, we try to take up an actual project and we do as it would be done in an actual design office. So this is what we do. And our impact for the learners, we try to always conduct impact assessment surveys after the completion of each course. And in our courses, we try to address multiple facets of learning. So we not only focus on conceptual understanding, but we focus a lot on software proficiency, because as engineers we need to understand the working and the ways in which your software will work, the limitations, the features, the advantages, disadvantages of using a particular software. So we focus a lot on software proficiency. We focus a lot on conceptual understanding of each and every aspect. That may be understanding of IS codes, or understanding of other international codes, or technical know-how, developing technical know-how. All these things also we focus on. Our courses also help our participants, and they create a positive impact in their work, because as I was telling you, many people are practicing professionals, and many of our participants are actual engineers. So they always give us this feedback that through this course they were able to uh, they were able to do well in their work, and through our courses they were able to use the learnings for their own projects. Many of our participants, after attending our courses, have themselves started their own firms where they take up projects, and where now they run their own practice as structural consultants. Many of them have got good jobs, and our participants also give us this feedback that our courses help them in their own interviews also. So, as I would like to highlight that our courses have made a positive impact for the learners, eh, uh, and they help our learners to achieve different objectives and aims. And in future also we'll continue to conduct such courses which help our participants in several different ways. So that has been our impact. A few things about us. So this is me on the right side. So I did my engineering from GSITS Indore, and then I did my masters from IIT Roorkee. I worked at Pune Dara Landasa Consultants for 2.5 years, and then in 2014 I came back to Indore, where we have our own structural design consultancy firm. And since 2015, as I told you, me and my wife, we have been also involved in these training programs. So on your left side, you will see Akanksha, and we both were classmates in our post graduation at IIT Roorkee. And she has also worked in different multinational consultancy firms. And as of now, she also assists and helps in this training firm that we have, which is Observe. So I think that was a brief few things I wanted to tell you about us. Now let me just go to the details of this course, and what are the contents that we would like to cover during this course. So the detailed course contents are: we will start with understanding the basic working of RCDC. So we will start our online course with with trying to understand what is RCDC, how it works, the basic features. So that will be our starting point. After that, we will learn about importing analysis files from STAD and ETABS. So as I told you, RCDC is not an analysis software; it is a post processor. So it will have to pick the analysis file from some other software. So importing those analysis files from STAD and ETABS, that is what we will learn next. With STAD, it is a complete integration now, as I was telling you, because it has the company has been acquired by Venti Systems, and it has been completely integrated into StatPro. So with STAD, it is just like a one-step process. For example, if you have been using Safe software for foundation design, so from ETABS to Safe, it's a one-click export, isn't it? Exporting ETABS file to Safe is a one-click process, because it is a that both those products are part of the same company. So similarly, STAD and RCDC, it's a one-click uh, process, because they are completely integrated. But things become slightly more tricky with ETABS, because as I was telling you, uh, they are not from the same firm. So bringing an ETABS file to RCDC is slightly more challenging, and you need to basically use a third party program, a database program that you have to use to bring the ETABS file to RCDC. So basically, from ETABS, we have to create a database file using Microsoft Access, and from there, we need to bring the analysis file to RCDC. So it's a slightly longer process because they are not integrated. But yes, we can do this work. So this will be our second sort of topic that we would cover, on how to import the analysis files from STAD and ETABS to RCDC. Then we will start with one by one we will move. So we will be moving from part to whole. So initially we'll start with understanding each and every we will start with understanding the design and detailing procedure for each and every element in RCDC. So we'll start with design and detailing of beams for simple gravity loads. That is what we will begin with. Okay. So we'll not go directly to the ductile design and detailing. We'll start with design and detailing of beams for gravity loads. We'll explore all the design and detailing features, how to set up reinforcements, how to check the section, everything we will do, how to match the calculations. So all the calculations that RCDC does can be accurately matched with your Excel sheets or can be accurately matched with your manual calculations. So we will also be using Excel sheets in this in this course to match the results or outputs that RCDC is giving us, because we need to be confident of what RCDC is doing. Only then we would like to use it for our projects. So this also we will do verification part. So verification of all the results we will do using some MS Excel spreadsheets or using some manual calculations, of course. So we'll start with the design and detailing of beams for gravity loads. Then we will move to design and detailing of slabs for gravity loads. Then we'll do the design and detailing of columns for gravity loads. Once these things are done, then we will do the ductile design and detailing of beams for seismic loads. So when I say seismic load, basically I am trying to say that we will do it by the provisions of IS 13920 which is the code for ductile design and detailing of RCC structures subjected to earthquake loads. So this is what we will do. Then Then we will do the ductile design and detailing of columns and joints for seismic loads. Again, by this I mean we will do the design checks as per 13920 In this, we will be doing the beam column capacity check also. We will do the joint shear check also, and the calculations for confinement reinforcement. All those things we will be doing when we are doing the checks for columns using the seismic loads or for ductile design and detailing. Then we will do for shear walls or RCC structural walls. Actually, the technically appropriate name is RCC structural walls. We should not call them shear walls. Technically, we should call them the RCC structural walls. Okay. So that is what we will be doing next. Design and detailing of RCC structural walls for gravity and seismic loads both. Then in this, just a minute. In this, we will be focusing on the design process as per 13920, and we will do a lot of calculations for the boundary elements. We will do the calculations for boundary elements for the vertical reinforcements, horizontal reinforcements. If you want to do a uniformly reinforced RCC structural walls, those calculations, all those calculations we will do, and we will understand what RCDC is doing when we do this topic. Then we will go for the design and detailing of isolated foundations, how isolated footings are done in RCDC, and then in the end we will do the design and detailing of pile caps in RCDC. So these will be all the individual RCC elements for which we will understand design and detailing. Then we will look at the BOQ calculations, how the BOQ calculations are done in RCDC, and then we will go to the topic of drawing development, preparation of bar bending schedule for the various RCC elements. So from part we will be going towards the whole, and in the end we will apply all the learnings of RCDC for an actual multi-story RCC project. I would like to add one more topic over here. We will also do the pedestal design. I have not included in the course brochure also, but I'll just announce this right now that we will do the pedestal design. In which type of structures we need to have pedestal design? Hello. In which type of structures do you need to do pedestal design? Tell me. Arre, no one. So pedestal design usually is required in steel structures, because in steel structures what happens that till base plate you have your steel. Okay, you have your steel structure till your base plate. So there will be a base plate, let's say over here, and then you will have your pedestal, and after pedestal you will have your footing. So this is my RCC pedestal. So many times we are in this, I should say, many engineers face this problem, that how to do the pedestals. So, as a part of RCDC, because we are doing a complete course on RCDC, I thought that this topic should also be included. So, I'll include it in the brochure also, and I'm announcing it right now that we will include the pedestal design also in our course. And pedestal design is required for steel structures where we need to provide a short column which we usually call as RCC pedestal. So that design also we will do. RCDC is able to identify uh, that a particular project is a steel project, and for that it is able to provide you with RCC pedestals. So we'll be doing that also in our course. Let me just clear the screen. Yes. So, what are the standards we are going to refer to? Obviously, IS 456 2000. I hope the IS 456 they revise it. I was reading that maybe this year they are going to revise, but even that we have been hearing for the past 4 years that IS 456 is going to get revised. Anyway, so we'll be using IS 456. We'll be referring to ISSP 34, which is the code on detailing. I'll be referring a lot I will be referring a lot to 1893 part 1 and IS 13920. And I forgot to mention, we will also be referring to ISSP 16 1980, isn't it? Which is the year for SP 16? Publication year? Hello. I think 1980. Yeah. So we will be referring to these standards when we are discussing, or when we are going to discuss RCDC, which are the softwares we are going to use during our course. So we will be obviously using RCDC, and we will be using ETABS and StatPro mainly to bring the analysis file. Okay, so I will not be discussing the modeling, load application, analysis in ETAB StatPro. That is not the intention of this course. Please note. So only for bringing the analysis file from ETABS or StatPro, we'll be using these two softwares, and then we will be referring mainly to RCDC, and we will be using or taking help of Excel spreadsheets for the verification of results. For the verification of results, we will be referring to these Excel sheets so that we are able to verify what RCDC is giving as output. Okay. Mr. Jay is saying SP16 is 1984. No, no, it's not 1984. I think it is 1980. So SP16 was based on the 1978 revision of IS 456, and after 2 years they brought out this document. Ever since it has not been revised. So 1980 is, I think, the last time SP16 was revised. I think now it has been discontinued also. So someone was telling me that now if you go to the BIS website, you're not able to download the ISSP16. So it has been sort of discontinued now. Don't know what they're doing. Anyway, so these are the things that we are going to cover. So as I told you, I will repeat, we will be going from part to whole. First we will cover, or first we'll understand each and every RCC element in depth, uh, and then we will apply all those learnings for an actual project. Okay, moving ahead. So this course we will be conducting live sessions, and live sessions will be in the morning 8:30 to 10:15 or 10:30, Monday to Friday. Those who are not able to attend the sessions live, because most of our participants are usually working professionals or practicing engineers or faculty people or students, or I mean everyone who has some work in the morning. So if you are not able to attend our live sessions, you can obviously join this course as self-paced learning course, where you can watch the online sessions as per your own convenience. So every live session we will record and we will put it on our portal, where you can watch those sessions as per your own convenience. And as I told you, most of our participants like to join our courses in this way, where they have the liberty to watch the sessions as per their convenience, and also they can watch it at higher speeds. So when you watch a recorded session, watch at higher speeds, the very big advantage that you get when you watch a recorded session is that you can watch at higher speeds. So usually I also watch my own sessions sometimes if I have to watch something, uh, just to revise or recall or recollect. I will also watch them at 2x or 1.5x speed. So I think that that is a great way of saving time, because in live sessions we tend to go a little slow, and our speed of speaking is also slightly slow. And if we are repeating a concept, then it unnecessarily is a time waste for those who have already understood it. So I think it's a great way to save time by watching the sessions at higher speed, 1.5x or 2x, which you can do when you are watching the recorded sessions. Anyway, so the sessions will be valid for 1 year, 1 year from the time the course ends. So whenever the course will end, 1 year from that, and they will be available for you to watch as per your own convenience for 1 full year. And then yeah, so every session we will have a doubt solving session also, and you can communicate with us individually, one on one also, and we will give you the e-certificates after the course completion. So who we think will benefit from this course? So as it's a basic course, I mean we are still keeping it as an advanced course, but because it's a RCC course, most of the participants or most of the engineers are involved in RCC projects. So I think this course will be a great course for the fresh graduates, postgraduates, for structural engineers who are wanting to start their work as consultants, or young engineers who are sort of looking to skill up, or even experienced engineers, those who are looking to deep dive, and obviously anyone who loves structural engineering and wants to learn more. So for all of us, for all of you, I think this course will be beneficial, and our intention is that through this course, we are looking that the participants develop an in-depth understanding of the RCDC software. The participant is able to understand the complete process of design and detailing of different RCC elements using RCDC, and not only understand the process, but our intention would be that we are also able to verify each and every result doing manual calculations. Okay, each and every element we should be able to verify with manual calculations. That will be our intention. Obviously we do it for all our courses. We do a lot of manual calculations and we do a lot of verification, because unless we do not verify, we will not be able to develop, or we will not be able to have confidence on the software. And if we are not confident enough, we will not be able to use the software. So I mean, then what's the use, isn't it? So we should be able to verify, and we should be able to understand the pitfalls of any software. Pitfalls mean where the software will have a problem. Every software has a problem. STAD has its own problems. ETABS has problems. RCDC has problems. Every software will have some or the other problem. Some of the problem you can make your way around. Some of the problems you have to live with, and for some problems you may have to do some jugaad work on your own. So at least as a user of the software, you should be aware of those issues. Okay, so through this course we'll be trying to understand all those things about RCDC. And we will be using the Excel spreadsheets to verify the results. So that will be a outcome which you can expect. Through this course, the participant will be able to use the RCDC for BOQ preparation, and using the drawings, which after some minor tweaking, you can use those drawings as a part of your own project also. So that will be one of the expected outcome from this course. And then the final outcome, or the most important outcome, will be that we wish to efficiently use RCDC as a post processor for our actual RCC projects. So these are the expected outcome that we wish to achieve through this course. And as a participant, you should also expect these outcomes to be met once we complete this course. Okay. So now how to proceed? So the course fee for this course is Indian rupees 4,500, and the methods and details for payment we will share separately with you. And then after the completion of payment, we will add you to our course WhatsApp group, where the further updates and links for daily sessions will be circulated. The course online sessions, or I should say the live sessions of our course, will begin from 25th March, Monday, from 8:30 a.m. These will be the timings for live session. Of course, if you wish to join this course as self-paced learning course, uh, the live sessions don't matter much to you. Even if you wish to attend this course as a self-paced learning course, you can also watch the live sessions. I mean, there is no stopping you from that. Okay. So before we take questions, just a few questions that I wish to answer before we move ahead. So I have already addressed this issue. So as a working professional, if you want to join this course, how you can do that? So if you are a working professional or a practicing consultant or a faculty member or a teacher or student, whatever, and if you are unable to attend live session, you can join our course as self-paced learning course. And as I told you, every session we will upload it online on our portal within couple of hours of conducting it. And we will, if required, we will organize periodic discussions or doubt resolving sessions for those who are joining this course as self-paced learning course. The next question that you may have in your mind, that you are fresh to RCC design, you are new to RCC design, can you join? So I would say that in this course we are looking at participants who have some basic understanding of RCC design. Okay, so in this course, please do not expect that I'll be discussing bending moment or shear force, or I'll be discussing the stress strain diagrams for concrete, or I will be discussing how we design a beam, or what is balance section, what is over reinforced, under reinforced, not those things. Okay, so we are expecting that the participants have at least some basics of RCC design known to them. The participants should also have some basics about the clauses and provisions of IS 13920 known to them. Even if in detail they don't know, it's okay, but at least some basics we would expect that the participants understand. And if you don't want, I mean, if you don't have the basic knowledge, if you want to develop the knowledge in RCC from the scratch, then I would recommend you to join our comprehensive course that we have conducted on RCC structures. You can also have a look at a course that we have conducted on design and detailing of RCC structures for seismic loads. And you can also have a look at our foundation design course. So here in this course, we would be expecting the participants to have some little basic knowledge about RCC design. Which actual RCC building project we will work on as a part of our course. So we'll try to take a RCC mid-level multi-story building that enables us to apply all the different options of RCDC that we have learned in the software. Okay, so we'll be looking at such a building. So maybe we may take two buildings, maybe one with RCC structural walls, one without RCC structural walls. Okay, so those we will be taking up as part of our actual building project. So I think these were some FAQs that I wanted to answer before we open up our session for Q&A now. So thank you for patiently listening. We are looking forward that all of you will join this course. We'll have a great time during this course. And now let's have queries from your side. Very good. So you may type in your questions and let's try to take them one by one. I'll just take in serial order in the sequence in which they were asked. So Mr. Rishabh is asking, in this course while designing multi-story buildings, will IS 16700 be considered? No, we'll not be taking a very tall structure. I'll be taking a mid-height building and we will try to discuss that. And please note that most of the provisions of IS 16700 are sort of provisions for the analysis, isn't it? So most of those provisions are at the analysis level. And as I told you, RCDC is a post processor which focuses more on the design part. It focuses less on analysis, more on design. So most of the provisions, as I told you, for IS 16700 are for the analysis. So anyway, they won't be much of a use in RCDC. And in any case, we will be taking a mid-height building for which 16700 will not be applicable. So yeah, so I hope that answers. So 16700 won't be covered. Mr. Yogi is commenting that taking drawings directly from RCDC is not a good practice. I think if you have looked into the detailing and if the detailing is as per your requirement, then you may take drawings directly as part of your good for construction drawings. Or if you are not very satisfied with the drawings RCDC is giving you, by making some minor adjustments, you can take those drawings. Mr. Rishabh is saying, can you show an example of output file? I'll be discussing that in the course. Each and every output file will be having a look in our course. Mr. Rahul is asking, RCDC output is good for large projects, but manual detailing is better. But these days, many structural consultancy prepare detailing drawings using RCDC to save time and labor. See, making a statement that manual detailing is better, I wouldn't agree with it, because if anything is there, a tool is there which is able to save your time and is able to give you outputs at a acceptable level of accuracy and efficiency, then I think there is no harm in using it. Okay. So big project, small project, I don't think that is a barrier. If you're able to use it for your own advantage, I think the scale of project does not matter. Mr. Yogi is asking, is RCDC only for designing? What about analysis? So I think I have answered this thing several times. RCDC is a post processor. It will only do design and it will do the detailing. It is unable to do any analysis. So analysis, if you want to do analysis, you have to do analysis using a software like StatEtabs and then bring it to RCDC. Mr. Weber is asking, RCDC will consider movements at face of column for beam or center. It will depend on how you have run your analysis. So for example, in ETABS, by default, ETABS gives you movement at face, isn't it? By default, ETABS gives you movement at face of the column. So beam moments are given at the face of the column. So if this is the setting you have made in ETABS, and if you bring that file to RCDC, it will also take the moments at face. Okay. If you change the setting in ETABS, there is an option to change the setting in ETABS using the joint offset command. And if you tell ETABS to please consider the beam movements at center of the column, okay, if you tell ETABS to please consider beam movements at center of the column, and then if you take it to RCDC, then it will consider the beam movements at center of the column. So whatever setting you do in ETABS, accordingly it will consider the beam moments. I hope I have answered. In STAD, as a default, as you all know, in STAD, the default setting is that the beam moments are considered at the center of the column. So that will be the value which will be taken if you bring it to RCDC. So whatever setting you have made in your analysis software, RCDC will take that. Okay. Struct architecture is asking. He has seen that ETABS column design and RCDC column design do not match. Have you tried to match the results? No, they match. They match. They match provided you know what are how the output is being calculated. So if you understand these, they will match. I think why it may not be matching for you, because RCDC uses a slightly different process for column design, which is called as the uh, what do they call it? The resultant moment method. Okay, so RCDC has sort of evolved, has developed its own method for the biaxial moment check, which it calls as the resultant moment method. Okay, so let me just take a minute to explain that. So RCDC uses a resultant moment approach. That is the default setting. Okay, the default setting is that it will use a resultant moment approach for designing columns and RCC walls subjected to biaxial movements. So what it does is, based on the moments about both axes, it will find out a resultant moment, and then it will, using the interaction curve, it will sort of plot that resultant moment on the interaction curve and accordingly give you the interaction ratio, isn't it? That is the default method that RCDC uses. What is the default method that our code tells us to use? What is the default method that code tells us to use? So code tells us to use what is called as the interaction equation method, isn't it? So in that, what we do is, about each axis, let's call the major and minor axis as x and y right now. So about each axis, we will calculate the analysis moment divided by capacity moment, raise it to the power alpha. Okay, and then we will calculate what is called as this interaction ratio. So that is the process that is usually to be followed by the code, and that is the same process that ETABS also follows, STAD also follows. But then these RCDC people use a process called as the resultant moment for biaxial moment design. Having said that, there is also an option in RCDC to go with the discrete moment approach. By discrete moment approach, I mean the same approach that code and ETABS and STAD Pro uses, which is the interaction based equation method, isn't it? So in RCDC, you have got both options. You can do the design using the resultant moment method. You can do the design as per the discrete moment method. Discrete moment method, I'll again repeat, is the process which is followed by the code and which is followed by STAD, ETABS, etc., based on the interaction equation principle. And RCDC as a default uses the resultant moment approach. So if you are going to use the resultant moment approach, you will see results different from the ETABS or codal results. Okay, but when you change the setting and when you start using the discrete moment approach, then your values will start matching. Okay, so values match. You need to understand the philosophy that is being used, and accordingly you can then verify. I hope that answers. Mr. Niyal is saying matte foundation, combined foundation. No, it will not be covered because RCDC is unable to do that. Mr. Rishabh is saying in RCDC, minimum percentage of steel for pedestal is 0.2%, while in code it allows 0.15%. I think there must be a setting to change the minimum percentage. there are settings, although I have not tried it right now, but there has to be a setting which allows you to change the minimum percentage. Mr. Jigar is saying, will you be covering detailed comparison between ETABS and RCDC results? Yes, especially for columns and RCC walls where difference is sometimes very huge. I think I have answered why the reason for difference, because RCDC as a default uses what is called as a resultant movement method, and it does not use the interaction ratio based method given in the code, which ETABS also uses. But in RCDC there is an option to change that to discrete movement method, which is the same as being followed in code and ETABS. So when you change the setting to discrete movement method, your values will start matching. So yeah, I hope that answers. Then Mr. Jigar is saying, does RCDC design flat slab systems? No. RCDC as a default designs the slabs using the coefficient based method. So it is not able to consider slabs as a FE element. It does it using the coefficient based approach. So if you want to do the flat slab design, then they have another software called as RCDC FE. So RCDC FE is able to consider your slabs properly, taking their stiffnesses in plane, out of plane, everything. So for flat slab systems, the software that you should use is RCDC FE. But I think if you want to do I mean, if you wish to do flat slabs, Safe is much better than any other software. Okay, Safe is the best. If you want to do a flat slab system, I would not recommend you to use RCDC. Just go to Safe. Okay. Then Mr. Weber is saying we will get output as long beam sections or tabular. We get them in both ways. We will get the L section and we will get cross sections at three locations. That is the midpoint at the ends, and we will also get the results in tabular form. Mr. Niyal is saying primary, secondary beams will be included. Yeah, beams will be included. Whether they are primary, secondary, we'll see. Whether we will also see how RCDC is able to identify if a beam is secondary, primary, all those things we will see. Mr. Rishabh is saying, are you planning on conducting a course on tall structure analysis? Maybe sometime in future. Maybe sometime in future. Mr. Yogi is saying, do we have a course on analysis plus design using RCDC? No, as I told you, RCDC is not able to do the analysis part. So if you want to understand the analysis, modeling, loading, all those things for RCC structures, you can have a look at our basic course in RCC design that we have conducted, which which deals with all these issues. You can have a look at that course. In this course, we have a very focused objective, that is of using RCDC for design and detailing. Mr. Jigar is saying discrete action. Yeah, that's what. So RCDC uses the discrete movement approach, uh, which is same to same as the approach given in the code. Basically, what is the meaning of discrete movement approach? That it will see, what do we do is that we have a three-dimensional interaction surface, isn't it? Those who are aware of the interaction curve, we have a three-dimensional interaction surface. In the discrete movement approach, what do we do basically? That we take projection of this 3D interaction surface on these two curves. So we will take their projection on these two curves, PMX and PMY, isn't it? So basically, we take projections of a 3D surface, 2D projection on a, we take a 2D projection of a 3D surface, and then we plot individual moments on these two curves. We find out the capacities, and then we use the interaction equation. That is what we actually do when we are using the discrete movement approach. In the resultant movement approach, basically I find out a resultant moment on the basis of the biaxial moments. I find out a resultant moment, and that resultant moment I directly plot on my PM interaction 3D surface. That is what we actually do. So this process the RCDC people have devised on their own. Our code only gives us one method, that is the interaction equation based method, which is the 2D projection of three-dimensional interaction surface. Mr. Struct architecture is saying, I have seen RCDC does not account for slenderness moment. No, it does. If your column is not slender, obviously it will not consider. But if your column is a slender column, it will consider the slenderness moments. Mr. Jigar is saying, does RCDC design slabs as per yield line theory? Yield line theory only. It will only use the yield line theory. It will not do FEM analysis. It's quite clearly given in the RCDC documentation that the slab is only checked as per the yield line theory, or what should I call it, the coefficient based method. Okay. Mr. Jigar is saying even for discrete moment method, difference is very huge sometimes. But as far as I was observing, uh, the results were quite okay. They were quite matching. I would recommend you to first just cross check the interaction curves that it is making. Okay. So what I would say is that wherever you are getting a mismatch in the ETABS and RCDC results, you first try to match the interaction curves. ETABS also generates interaction curves. RCDC is also able to give you the interaction curves. So you match those. If those interaction curves are matching, then it should give similar results. If the interaction curve is not matching, then you need to look into uh, the reason for mismatch. Okay, clear? Yeah. Very good. Any other question that anyone has? Mr. Vijay 4560 is asking, sometimes the column passes in ETABS and stat tends to fail in RCDC. So as I repeatedly told you, RCDC as a default uses a slightly different approach for column design and for RCC structural wall design subjected to biaxial movements, which is called as a discrete movement approach. And when you are using that method, it does happen that it will show you columns that may pass which were otherwise not passing in ETABS or StatPro. That may happen. Uh, so as I told you, that discrete movement approach is as such not given in the Indian code. So technically, you should not be using it as such. Okay, just give me a minute. I'll be back. Yeah. So then, what is the next question we have? Struct architecture is asking. I have seen RCDC does not take additional movements in columns mentioned in ETABS for design. No, no, it is able to take. You should go and check the detailed design. If it's not applicable, if your column is not slender, then obviously it will not take those additional movements. Otherwise, it takes. There's no problem with it. Yes. Any other thing? Any other question you would like to ask? Very good. So I think we had a good session and we are hoping to see you. We are hoping to see all of you in our course. Mr. Nihal is asking how to pay the course fee. I'll be sending a message. Please look into our groups for updates. I'll be sending a message. with payment details. Mr. Shubham is asking, when we design fixed beams in ETABS, the support moment is sometimes so huge that tension moment is too negligible. And if we take the same result in RCDC, it may get wrong. Eh? I'm unable to understand the question. Tension moment means? No, what is the meaning of a wrong result? It may be showing you failure, but what is the meaning of a wrong result? I could not understand. Yes, anything else? So I think we had a good session and we are hoping to see you. We are hoping to see all of you join this course and we will have a good time. After many days, we are going to conduct a course on RCC. So we are also looking forward to it because for a while we were conducting courses which were on steel structures one after the other. So after a long time, we are going to conduct a course on RCC. So we are also feeling excited with change in the subject. So we'll have a good time and we expect and hope to see all of you in the course which will start from 25th of March. So that's all we have for today. Thank you and hope to see you from 25th. Bye bye. Have a good day. Have a great weekend. And yeah, that's all.